Okay, now let's talk about some probability lingo. Okay, so mathematically speaking, we use the word P, the letter P, for the probability of the event. This is how we write it: probability of the event occurring, and we have some probability. Okay, A over B. Now to demonstrate it, let me go ahead and create some sample space. Let's create some sample space here. Now let's say these are my points. Okay, these are my points 1, 2, and 3 on the x and the y axis. Now if I ask you the probability of, let's say, occurrence of 1 1, what is it? Well, out of the total we have here 12 of them, so total event is 12. Out of them 1 1 occurring is just 1, so this occurring is 1 out of all of them, and this is how you write it: probability that 1 and 1 occurs. Or let's say probability that, this is suppose my x-axis and this is my y-axis, probability that x is greater than 2. So x is greater than 2. Okay, so these are the areas where x is greater than 2. That means probability that x is greater than 2. Now this is going to be equal to this whole over all of them. All of them is total is 12, we know that. Now this one here is 6, and there we go. X greater than 2 is 6 of them. 6 over 12. Well, turns out it's exactly half. Now let's move on. Now let's say I'm given a diagram which also holds some sample spaces. So let's say I have A here and I have B here. And now let's say we're told to find the probability of A or B. Well, if you're familiar with set, we know what it is: probability of A union B. That's what it is. So in other words, in this scenario, it's going to be probability of A plus the probability of B. There we go. Probability of A, all of them here, occurrence, plus this occurrence. And when we add these two, this will give us both of their probability together. And this is something we call as the addition. It's the addition rule. However, here's a catch. Let's say I have another sample space where A occurred and B also occurred, but now there are intersections in there, so there are common things between A and B. Now this will not work because adding A and B will basically generate this redundant bit here, so we'll have to get rid of that. This is something we call as mutually inclusive. See, A is contained on B, some part of A, B contains. This is something we call as mutually inclusive. That is, A and B contain some portion of each other, whereas above we had an exclusive event, mutually exclusive event, so we basically perform the addition. But now here, when you perform addition for the probability of this A or B, when you add it, let's say when you add it, probability of A plus the probability of B, well, this is going to generate this extra redundant of the intersection. So I gotta now remove the probability of my intersection, so A intersection B, and this here, right here, is what we call as the addition rule. So this is going to be probability of A plus the probability of the B minus the probability of A and B occurring, because you got to remove the redundant, and this is the probability of A or B. This is our addition rule right here. Let's move on. Let's say we are given let's say this is our B and we have A here. Now we want to know the conditional probability. What is the probability that B occurs given A? So this slash right here basically means given. Probability that B occurs when A is the sample space. So when A, this thing right here, when this is the sample space, what's the chance that B occurs? Well, it is this chance, isn't it? This is the chance that B occurs, which means this is the common thing between A and B. Well, we can write it as the probability of A intersection B, the common thing between A and B. And now occurrence of it obviously is the probability. You're going to divide common thing divided by the whole thing. So whole sample space is this thing. This is our whole sample space, and this is represented as probability of A. So the whole sample space and this occurrence, probability of B occurrence, is this thing right here in the whole A. So this middle is our intersection of A and B in all of A. And now we could do some algebra in here. Let's do some interchanging. So probability A intersection B is going to be probability of, let's say, A times the probability of B given A, when A is given. And this is what we call as a multiplication rule. This is our multiplication rule right here. So probability of the A intersection B, this thing right here, to find it, we'll multiply the probability of whole A times the probability of B given A occurring, which means when we multiply, now this is going to give us the common element. So now that we're equipped with these two great concepts, let's go ahead and try to solve some questions. Let's say I have a Venn diagram right here, and let's say I have B. Let's say this is my B, and let's assume this is my A. Let's say this is my C out here, and let's say this one outside is my D. This whole of them is my D. Now I want to find the probability of the occurrence of B. Okay, now what's the probability of the B here? Well, obviously this portion is common with A, this portion is common with D, and this one is common with C. So it means when we add all of this probability, we'll get the probability of the B. Now this one, as you can see, is the probability of B given A. There we go. Plus the probability of the B, this middle portion is going to be the probability of the B given D. It's given D plus the probability of B given C. And now we'll go on to use our rules. So probability of the B given A, well, it's going to be now probability of A intersection B whole over probability of A plus probability of B intersection D whole over probability of the D plus the probability of B intersection C, the common thing, whole over the probability of C. So C. And now this is how you find the answer of probability of B.